So our next presenter, the creator and founder of the B2B, the back-to-back, I'm hoping
Woo!
that by the end of this presentation,
I know what
we're
you're
going to
going
get
to
one.
You're going to ask him to do the back-to-back dance, aren't you?
I'm hoping. That's it. I'm just letting him know that there are people out there that want to see this.
Great idea. Great idea. Come join us. Come. He's our hero. Yay!
So without any further ado, ladies and gentlemen, Giovanni.
So this presentation will be about how to scale services, specifically voice over IP, both the classic one and web RTC, and particularly using FreeSWITCH and OpenSIPS as building blocks. And so probably there will be many known things for all the old bands in FreeSWITCH and in OpenSIPS, but I hope to do some cross-pollinating between the two communities. And without any more waiting, let's go to the slides. So I'm Giovanni Maruzzelli. I'm a consultant. It's a very long time that I'm in this industry. I wrote some book and done some speech. What is to be done when you build a web service, a SIP service for a customer, and particularly for an ITSP or for a carrier, or something like PBX in the cloud, or services for residential or small medium enterprises. You have many building blocks that you must combine in the best possible ways and to deliver something that is reliable and that makes sense from a management point of view, because apart from day one, you then have some years and years of operations, and so it must be operable. So you have security, high availability, and then you must deal with registrations. So you take count and you keep where each phone is and how to reach to that phone. Then you manage presence, BLF, NWI, and those are all the lights, the little LED that are on the business phones that tell you when someone else is on a call, so you can forward him another call, or he is busy. And or if you have some message waiting for you in your voicemail, then you will have the blinking light that tells you, please push the button and listen to your voicemail. And then you have calls that are internal to your customer network, so extension to extension, let's call it. Or you have calls that from the external world, from PSTN or some other gateway, want to reach your customer, or vice versa. Then you have all the particular services that are like IVR, automated attendant, conferences, queues, automatic call distribution, transfer, all these special cases. And then you need to deal with NAT, Network Address Translation, that is almost for sure the front end of your customer. So you can't reach him directly. You must pass through his own little router that often is not very reliable. So let's approach one by one all these parts and let's see how we can solve each part using FreeSWITCH and OpenSIPS. Security. There is this buzzword SBC, Session Border Controller, that more or less is devoid of any meaning, because in the industry, this kind of acronym is used to denotate totally different things. So we will try not to use this SBC word, but let's talk in terms of what is our front end or single point of contact with the internet, and we will see that in our architecture we tend to use one only point of contact with the internet, so one only public address, and all the rest is behind in a private network that is not reachable from the public internet. That means, in a way, very easier to secure than having multiple point of contact with the internet and multiple machine, multiple systems with different architecture, etc. And obviously, you will need to use a specific feature of your operating system that will probably be FreeBSD or Linux, and so you will use its internal firewall that can be PSEC, IP table, or whatever, and then you use on OpenSIPS the modules that give you a first line of defense in terms of denial of service, in terms of checking if there is nothing particularly strange. You can also filter for user agent, so you can filter out vicious, people clear, etc., etc., all the easy spottable probes that comes from the internet. And this is, let's say, the first line of defense of you. And then you have the high availability. You want to have your service that's reliable, that can survive the crash of the machines, and that automatically make good from any damage that can happen. So first things first, double your OpenSIPS. That's your point of contact with the internet, and the RTP proxy, that can be RTP proxy proper, or RTP engine or media engine, etc. And so double or multiply those machines so they can survive a crash, and in the easiest way and the simplest way, you will have two such machines that are in active-passive, and you will just move the virtual IP address from one to the other with keep alive. That's a daemon that do VRRP to moving the IP addresses, and you will use it, this keep alive with some functional testing, so you can be sure not only that the machine is up, because many times the machine is up, but the SIP calls do not terminate, and so you must check in collaboration with Keep Alive. You can use a test program that will communicate with Keep Alive about the health of the platform. So if the calls are not terminated or other tests are not successful, you will change the status and you will fail, and Keep Alive will move the external IP address, the virtual IP address, to the same machine, and the service will continue seamlessly. While let's see, this is the picture that I often use for my presentation, is 10 miles in the sky view of the whole platform. You have on the far left, you have this yellow rectangle. That's your gateways to the PSTN and to other carriers. Is from where your DID's calls comes into your platform, and is where you send the calls to the external world, so to carriers, to mobile operator, etc. Then a little bit up, you have all the phones that are in the customer premises. So they are both desk phones, or they are app on mobile, or they are web RTC on the browser. And both the ITSP and the customer phones will connect to our single point of contact with the internet. That's our two machines in active-passive that do SIP proxy and RTP proxy. And then on the we pass in the internal network that is not reachable from the internet, and we have our FreeSWITCH server farm with our Postgres SQL cluster and our cluster FS cluster that give us a redundancy for both storage, persistent, and for file system. First things first, we need to understand what is the correct role for each actor. And we must ask to each one to give his best for what is able to do. And so you will use FreeSWITCH as a media server, as an application server, as a business logic. So it's a platform that gives you a very easy way to program very complex logic using complete languages like V1 for your interaction with databases, with your CRM, with your customers, etc., etc. So very complex and very high-level functions will be taken care by FreeSWITCH as a back-to-back user agent. Back-to-back user agents means that is acting like two phones connected into one. So it will receive a call, it will answer a call, and will originate another call, a new call to the peer, and then it will bridge the two calls, making the media stream, so the voices or the video, go back and forth between the two endpoints that are connected. So you will use FreeSWITCH for all its very advanced capabilities in terms of media and in terms of interaction at high level. OpenSIPS is a proxy, and it's able to do all the heavy lifting that you need into a telco operation, and particularly it shines so much in all the high frequency, high volume transaction per seconds area. And this is where you want to use definitely OpenSIPS because it's so much more efficient for doing hundreds, thousands, or almost millions transactions per second into using the proper hardware. And is order of magnitude more efficient than FreeSWITCH. And that's completely logical because it's a totally different piece of software and with totally different aims. So you don't want to misuse FreeSWITCH, and you don't want to try to coerce too much complex logic programming, and particularly media programming into OpenSIPS. So to each one its own, or from each according to his ability.
Giovanni,
Yeah.
just in respects to this kind of a separation you did over there, over here. So in this slide between what each party is doing. I mean, FreeSWITCH versus OpenSIPS. I will show tomorrow some magic that will definitely move a bit this border between what each can do. So that just a kind of a heads up.
I know very
things
well.
are not anymore so well defined right now.
Exactly. I know very well that, and if you remember when you were introducing this OpenSIPS distributed 2020 edition, I told you, I mean, you are totally moving the border, and I mean, the more and more you will be able to move many functions that up to now were better handled by FreeSWITCH into OpenSIPS, and FreeSWITCH will be more and more particularly on the high media capability thing. But we will see, and I'm so enthusiastic about the new things that you will be presenting. So let's start with registration. Registrations are the most high-level transactions that are running around in telco, particularly if you want to be very reliable. I often use 120 seconds for registration. That's because I don't want to leave too much gaps into knowing exactly where all my customer phones are. And this is when you reach some real numbers, this is a totally impractical frequency to manage to FreeSWITch, because as many other kind of transactions is just too much. And so you definitely want to manage this via OpenSIPS. But how you can do this? You can do this with a specific module that's called mid-register. This mid-register, what he do? It acts like it was the normal register for OpenSIPS. So it do client registration, it do end use endpoints registrations in OpenSIPS. But it has a function on top of it, and this you can tell mid-register that each, let's say, 1 hour, it will send the registration to FreeSWITch. So in this way, it acts as a demultiplier. And so it will receive a registration each 2 minutes from endpoints, but it will send only 1 each hour to the FreeSWITch. And when you have all the FreeSWITch farm on the back, and the FreeSWITch farm and the FreeSWITch farm has its own internal backend on database. So OpenSIPS will send a registration to one random FreeSWITch part of the farm, and they will all share this registration immediately because it's in the database. One important tip to remember is that it will be very valuable, very handy to you to have a script to reload from the mid-register to the FreeSWITches all the registrations, particularly if you purge, if you clean the registration database of FreeSWITches, you want a mean to repopulate it at your will and not waiting maybe 1 hour for the next for next time OpenSIPS will send the registration. Then another very heavy area is presence and DLF. So all the things that are generated as a statuses when there are calls going on certain phones. And for example, in office is very often you have all the blinking lights that tell you all your colleagues if they are in a call or not, if they are busy or they are free to accept a new call. And this compounds. So if you are 20 people in an office and each one people monitor the call status of all the others, you can understand how many of this monitoring is going on. And for each blinking light status is a message or more than a message, and all the transactions that goes around, and you definitely want to have this managed by OpenSIPS, because it's heavy lifting. And you can use FreeSWITch for all the things that are ready-made for you in a smart way that are already integrated, for example, into FreeSWITch itself or into Fusion PBX or other platforms. For example, using some light Lua scripts for sending a message waiting indicator, MWAI, that tells you you have some voicemail waiting for you. And one tip here is you can reach the OpenSIPS generated notify in case of presence and DLF using the local route. And there you can manage to massage, alter, edit the content, XPDIF, or the content of the notify, so you can make it compatible and with a specific kind of phones. This again to refresh our view of the platform. And so let's see the calls. We have two different parts in the call management. One part is about the signaling, so the specific SIP part that denotates who is calling who in text. And another part is the media, so the SDP that contains the in text where to send the audio and or the video, and where you get the video or audio from. And the problem is that in the totally different way than HTTP, than web, in SIP, in real-time communication, you have those two series of addresses, so the signaling and the media addresses, that must be related and managed, but that normally are not managed automatically, but by the network, because they are written as text into the messages. So we must alterate those messages and manually change those addresses into text messages. So we must parse the text messages and alterate those addresses. And we will see that is kind of complex, because you have a flow into the message and a flow into the reply. And each one must be managed. So in FreeSWITch, you have the concept of profiles. SIP profiles in FreeSWITch are a couple composed by internet address, IP address, and port. So you can have many such profiles. Normally are on the same address, but different ports. And you give these profiles different properties. And normally, by convention, there are two profiles. One is called internal, and one is called public. The internal profile is the one that got a default dial plan. This is also named by convention. And is where you connect the internal phones, and is a trusted environment where you can accept the calls, send the calls, use PSTN gateways, etc. This is, let's say, your local area network where you connect your phones. This is FreeSWITCH. Huh? And then there is another profile that is called public that we will see that is a not trusted environment, is the one that connect with the provider or the DID provider or the ITSP, and so through the internet, and that profile will not have the possibilities to do dangerous things like using for pay gateways, using services, etc. It's an untrusted environment where that you use just to receive calls or to send calls to your ITSP. So those two main difference profiles, I repeat, one is used to manage the internal PBX services, and the other one is used to manage the connection between the PBX and the external world. This is from the start of FreeSWITCH as a complete PBX environment that will connect directly to the internet. We use FreeSWITCH as a tool set for our complex and scalable architecture, so FreeSWITCH will never connect directly to the internet, but we will have usage for those two profiles the same. So in our platform, phones only register and deal with OpenSIPS. And OpenSIPS is the only point of connection with the internet, is the only things that is connected to the external world. And phones will never send signaling or media to FreeSWITCHs. FreeSWITCHs are actually not even reachable from the public internet. All is passing through OpenSIPS and our RTP proxy that will route the media, etc. FreeSWITCH knows that the phones are registered to OpenSIPS and will receive and send the calls to OpenSIPS. This because mid-registrar will send to FreeSWITCHs a carefully crafted registration that will make FreeSWITCH to connect to OpenSIPS and not to directly to the phones. So when FreeSWITCH wants to reach a phone, it will pass through OpenSIPS. In this way, FreeSWITCH will treat all that comes from the port 5060 of OpenSIPS or another port, but a defined port into OpenSIPS will be treated by FreeSWITCH as its own internal traffic. So it will use, if the call comes from that IP address in that port, OpenSIPS, it will use the internal profile, FreeSWITch profile, and that has the dial plan that give all the PBX services. Important, don't use port 5060 as your public internet OpenSIPS port. Use another random port, I mean, whichever you choose, for example, 5070, and you will save the burden of being continuously probed by the internet wannabe pirate. And this is not a problem because you will keep them off, but it just, I mean, they will pollute your logs and why to accumulate the records of their probes. So we have our flow that comes from the phone that is on customer premises behind router, so it's probably NATed. I mean, 100% is NATed, and it will arrive to OpenSIPS. OpenSIPS will send the phone the RTP proxy address into SDP and send to FreeSWITch the RTP proxy internal address to FreeSWITch. So at the end, you will have RTP that will flow from the phone to RTP proxy to FreeSWITch and then back. And this in case, for example, the customer is calling an IVR in FreeSWITch. And so there is no bridged call, but it's one leg call. And when you have an internal call between two extensions of the same customer, you will also have a flow that is very similar. So remote phone will get RTP proxy address to send the media to, and FreeSWITch will get the internal RTP proxy address to send the media to. Then FreeSWITch will originate a call and give it its own SDP address, and the call will transit through OpenSIPS and RTP proxy and reach the peer, the phone B. And so all the RTP will flow from phone A to RTP proxy to FreeSWITch. Then FreeSWITch will route the SDP, the RTP to the newly generated, originated call to phone B, passing through RTP proxy. And when the call is established, you can then do some reinvite, for example, to not having FreeSWITch in the media path and having the RTP, the media, the audio or the video, going directly through RTP proxy without passing by FreeSWITch, or directly staying the LAN between the two endpoints. Experience told that the best way and the most reliable way is to keep the media flowing through RTP proxy, so it's reliable also if endpoints disconnect or change network or whatever, and keep the signaling passing through FreeSWITCH so it can intercept all kind of signaling, particularly on hold for generating specific customer music on hold, and other kind of signaling like refer, reinvites, and things like that. Also, when you keep the signaling going through FreeSWITCH, it helps you because then you can generate reinvite when it happens to need audio from FreeSWITCH, not only in case of music on hold, but for example also if there is need to do recording during a call, or when you need to do text-to-speech or automatic speech recognition during a call. Again, our picture. And let's see how it works from external. I see that the time is running short, so I will go very fast. More or less, let's say that with PSTN, it works the same that for internal calls between extensions. The difference is that passing through a specific port, both in OpenSIPS and in FreeSWITCH, it can choose and it will be forced to use a specific SIP profile in FreeSWITCH that is enormously more restrictive and that will correctly distribute the DID to the internal extensions. And obviously, you want to firewall your external port of OpenSIPS, the one that connects to the gateways and the ITSP. And I will go fast in this. Okay, let's jump to the special cases. And normally all the calls are just dispatched in a from OpenSIPS to one of the FreeSWITCH servers in an algorithmic way that can be random, can be round robin, can be weighted for load or whatever. But there are cases where you don't want your call to just go to one FreeSWITCH by an algorithm. You want a related call, related call from the point of view of FreeSWITCH to stay on the same FreeSWITCH machine, particularly the ones that need to have their audio, their RTP streams mixed into FreeSWITCH. So conference rooms, queue, call centers, and things like that must be on the same physical FreeSWITCH machine, or that machine cannot mix the audio. And there is kind of easy way to conceptualize this, and you identify the to which extension, and an extension can also be an IVR or a service, say on a queue or whatever, to which extension the call is going, and you keep track of it. And if there is another call that is or going to or coming from an extension that is the same or related to that extension, send it to the same physical machine. And so let's say you, by default, you use an algorithm to distribute the calls on whatever machine the algorithm deem is the right one. But in case you check in the database and see that one incoming call is related to some calls that is already ongoing, then send it to the same FreeSWITCH machine. Another special treatment that you need to is keeping care of NAT, particularly of keeping a pinhole into your customer router open, so you can send them call. The things that often happen is that they can call, but they can't receive calls, or that you have some sort of one-only way audio or things like that. Often all these things are made because the router on customer premises is closing ports or closing pinholes. And so what you want to do is keeping that open, sending option messages. This also is exactly what you want to do from OpenSIPS. FreeSWITCH can do that, but you don't want to use it to do this in an industrial grade environment, because it's just too much transaction, and also the mechanism of FreeSWITch is too much heavy to go to the big numbers on this. And it do each time a check on database, etc. So you want definitely to use this from FreeSWITch, and you can add to that also as a tip a periodic reinvite, let's say each 1 minutes or so, just to be sure, particularly with TCP-based communication, that they have not disconnected, or ports are not closed, or they have not changed the network. And okay, we leave 5 minutes for questions and some trivial tips. And use OpenSIPS to do the trace of SIP messages and send it in using the HEP protocol. And so you will be able to visualize a complete SIP flow from also from TLS and WebRTC, things that you cannot do just intercepting the network flow because it's encrypted. And so you will be able to use both Homer and SNGREP to visualize what you send to them through HEP protocol. And use aliases. Aliases are a feature that is not very known, but you can have aliases both in SNGREP and in Homer. So you will alias all the addresses of your gateway or your proxy or your media servers and give them some names. And so they will be shown into the ladder graphics and the SIP flows. And it will be so much easier to understand the ladder, and you will easily see which one are the phones in the customer premises, which one are the gateways, which one are the proxy or the media servers. And use directory trees. This is particularly important if you use network storage like NFS or Cluster FS or etc. Because all network storage has a heavy cost in listing directories, particularly if they contain many files. So if you create a directory with, let's say, 10,000 files, that is not so much, that is nothing. If it's on a local directory, because they will be kept into kernel space, into the file system cache. But if you are using some network storage, you will block and stay for 5 minutes just to receive the listing of the directory. So do directory trees. You can organize as you want in a random way or in a logical way. But use directory trees. For example, in this slide is year, months, day, hour for accumulation of related time-related files. Another trivial tip that comes to my mind is when you are looking at the name pane of SNGREP, where there are the list of the calls, if you press capital A, the cursor will go to the last call and will self update, staying always on the last calls. So it's actually keeping you on current without you to press the arrow keys. And
nice.
There are maybe
These are not trivial tips, by the way. I don't think I knew 2 out of 3. Thank you.
No, thank you to you to be so nice. And but both of these things, for example, particularly SMGrep, has many of those tricks. For example, also when one important things that you want to do is particularly on back-to-back user agents like FreeSWITCH, and this is important also for Homer. When you originate a call, you originate it and add an header, an X header with X call ID that will report the call ID of the call that has originated the new call, the one or more new calls. This will give you the possibility in SNGrep and in Homer to click on the original call and see the complete flow with also the other legs. So you click on the A leg and you will see one ladder with all the B legs that are originated from the A leg. And when you are seeing that, if you press multiple times C to have the ladder made with coloring for call ID, you will have so beautiful and easy understood ladder by the various call ID, and if you use aliases, it will be
So
the best possible.
just to recap what you said, all we have to do is to include the X call ID header, and both
Correct.
SNCF and Homer have the necessary code to pick it up, right?
Correct.
Wow. So it's X dash call dash ID, or
It's, I'm sure it's multiply documented, and it's X
I'll look it up
X
for you.
dash call ID. I think is X dash call ID.
I got some questions from, or not questions, maybe some
I
comments.
can show
For you,
you
Giovanni.
one. If you have just time for. Really, I will just show you because it's nice.
It's X dash call dash ID.
Yeah.
Or I think there is a shorthand version. Not sure if this is correct. X dash CID. Shorter.
That's probable, but I will show you one.
Maybe we should move to the questions.
Okay.
We are a bit late to the time, so.
Okay, just.
And people are, of course, anxious to get the truth from you.
I'm anxious.
Yeah, see, Maxim, it's very, very anxious. He wants
Yeah,
the truth.
Giovanni, well, we're waiting. Thank you, Bogdan. We're waiting for people maybe to post some questions on the chats. Just a quick observation, or not so much observation, maybe some ideas on what needs to be improved. With all that crazy stuff that you displayed with people sending call to RTP proxy and then to FreeSWITCH and do some processing there and then sending it out. We came to few cases where that did not play very well with the NAT detection. And they basically ended up creating like 2 sessions in RTP proxy, like one in, one out, and then this FreeSWITCH tried to drop out by sending some re-invites. But what happened is basically the proxies keep kind of loop going, so it never really released that. So there's some documentation, maybe, I don't know, or some improvements to be made on that end.
Actually, is one of the most interesting things for me, and there are many moving parts in all this. You have the phones, you have the FreeSWITCH, and you have OpenSIPS and RTP proxy. In FreeSWITCH is, let's say, made, I mean, the spontaneous behavior of FreeSWITCH is to behave as he is alone in the world, and he is directly connected to the internet. So he has no idea of a proxy or not for media, not for signaling. Is an all-in-one package, let's say. And also is an all-in-one package that is a little bit of an hybrid, because obviously it must also behave a little bit as a proxy, or for example, as a register or things like that, but is a B2B. So complex things. You have to coerce FreeSWITCH not to do things, not to do its own idea of how to do the reinvite, its own idea on how to do the refer, etc., etc., etc. So it's to tame FreeSWITCH, not to take its own initiatives, its own idea of how to deal with things, is an endeavor into itself. And then you want to substitute those things with your things because you want to have music on hold, refer, or things like that. You want to be able to reinvite and move the RTP stream from the tree level between phone and phone, between phone and RTP proxy, or between phone, RTP proxy, and FreeSWITCH. You want to be in control because the platform is yours and you want to decide things. And this is a little bit complex, and it requires you to control strictly FreeSWITCH. For example, it has a lot, really a lot of control on how to move the RTP stream, and how to do that if there is a music on hold or invited. But it's all high level and let's say automated, and are all those things that I mean, for example, into browser that they you begin to write something at if in the browser complete for you and probably is not what you wanna write, or T9 on your cell phone, etc. So you must keep a lot of attention, and it's really is a complex art.
Anyway, thank Giovanni. I think Alex is looking at us very angry. So
I'm looking at the timer, but it's all good. These are great questions. That's why we still have the Summit chat and the YouTube chat open. So if you guys want to continue the discussions, you can do that there.